Okay, let's look at another example of integrating using inverse trig functions. This is a little bit more sophisticated example um, because the numerator here is a little bit more complicated than numerators we've seen in the other examples. So here's what I'm going to do in order to find the antiderivative for this integrand. I'm going to actually break this up into two fractions. So I'm going to write this as x over the square root of 4 minus x squared, and then plus 2 over the square root of 4 minus x squared. And then, now that I've got two terms, of course, I'm going to break this up into two separate integrals. So I'm going to write this as the integral of the first term, x over square root of 4 minus x squared, and then plus the integral of the second term. Now, what this allows me to do, breaking this up into this integrand up into two terms, into two integrals, is it allows me to approach these two integrals with slightly different techniques. This first integral, I'm going to integrate using the anti-power rule. So I'm going to write this as this integrand as x times 4 minus x squared to the minus 1/2 power. Um, of course, square root of 4 minus x squared is 4 minus x squared to the 1/2 power, and since that's in the denominator, we can bring that to the numerator by um, using a negative sign on the exponent, right? Um, and this integrand, I claim, uh, can be integrated using the anti-power rule. The second integral, I'm going to factor out this 2 in front of the integral sign. So that's a constant, so you know you can factor that out, right? And then the second integral, I'm going to integrate using the arc sine function. All right, so let's take these one at a time. First, let's try using the anti-power rule on this integral. So I'm going to make a substitution here. I'm going to let u be equal to 4 minus x squared. And then, of course, let's take the derivative so we can eliminate also the dx. So we have du over dx is minus 2x, or solving for dx, we have dx is du divided by minus 2x. And so when we make substitutions there, we'll get the integral of x, then times u to the minus 1/2 power, right? And now our substitution for dx is du over minus 2x. And see, notice here, the x's will divide out, of course, right? Okay, and so that's good. And this minus 2 in the denominator, we can factor that in front of the integral sign. So when we factor that out, we get minus 1/2 times the integral of u to the minus 1/2 du. And that's easily integrated using using the anti-power rule, right? So we would get as the integral minus 1/2 times u to the positive 1/2, right? Adding 1 to the 1/2 gives us positive 1/2, and we'll also divide by 1/2, right? And now the 1/2s are going to cancel because we're multiplying by 1/2 and also dividing by 1/2. The minus sign doesn't go away though, so I end up with minus u to the 1/2 power. Let me see if I've got some extra paper here. And now we can unsubstitute here, right? So we have minus, let's see, what was u again in this substitution? I think it was 4 minus x squared, correct? There it is. So we have minus and then 4 minus x squared to the 1/2 power, which of course is the same as minus the square root of 4 minus x. This is supposed to be squared. All right. So there's the first term, the first integral integrated. Now let's do the second integral. All right, so for this substitution, this one is a much simpler substitution. I'm going to try to use again the arc sine function to integrate this second integrand. So we'll just let u be equal to x, and then of course du will just be dx in that case. And then the a value is going to be 2, right? Because 2 squared is equal to 4. So we have 2 times the integral of 1 over the square root of 2 squared, of course, minus u squared, right, times du. And this is the perfect situation for applying the arc sine function to find the antiderivative. So we will have 2 times, let's see, I think this is going to be the arc sine of u over 2, right? Okay. This is u over a. In this case, a is also 2, so don't confuse these 2's here. And so altogether, we end up with, let me shift all the way to the bottom here. When we undo the substitution, we have 2 times the arc sine of x over 2 because we had substituted u for x. And then don't forget that at the end we need to add on our constant. So there is our final antiderivative there. And you can write, I didn't do it here because I ran out of space, but you can write the 4 minus x squared to the 1/2 power as the square root of 4 minus x squared.